Hello dear students, how are you all? Hope all of you are fine. Today I want to ask you something, that when you go to grocery shop, what you get there? You will always get grocery from there. You will not get clothes from there, for sure. And whenever you go to any stationery shop, there you will get only stationery item, not any electronic item, right? Also, in mathematics, whenever you operate or you do operation between numbers, like when you add numbers or when you subtract number, multiply number, that time always you get number. So in integers also, when you apply operations between integers, you will always get integer, and hence this property is called as closure property. Let's take few example. Like if I take integer 6 plus 3, 6 is also integer, 3 is also integer, I will get 9, right? And if I take 4 plus minus 2, what I will get? I will again get an integer, that is 2. So in both the numbers I have used an operation, that is plus. But what will be the answer if I use operation minus? Let's see. If I minus 6 and minus 3, I will get 3. 4 minus 2, I will get 2. So in each case I will get integers only. Let's see this property in multiplication. So if I multiply 6 and 3, I will get 18. This is also an integer. Or if I multiply 4, 2, I will get 8. 8 is also integer. Now we will check whether the integer closure property will fulfill in division or not. So if I divide 2 and 4, 2 divided by 4, what I will get? Will I get an integer or not? So you can see I will get 1 by 2, which is not an integer. It is not an integer. That means the closure property will fulfill for operations like plus, minus and multiplication, but not for division. So here you have understood that whenever you do operations between integers, you will always get integer. Only in division the condition will not fulfill. Now this we have understood about the closure property. There is another property that we will going to discuss. Now I will take few examples, and by that we will understand the other property. Okay, I have a piece of paper, you can see. Now you can count the numbers. How many figure you can see over here? It is 3. And here if you count, the figure number are 4. 3 plus 4 is equal to 7. Now if I change the number like this, now this side the number of figures are 4 and this side the number of figures are 3. So 4 plus 3 is equal to 7. Whether I put 4 here or 4 this side, or if I change the place of the number, we will get the same result. That means 3 plus 4 is equal to 4 plus 3. Right? So also you can say A plus B is equal to B plus A. So what we will call it? We will call it commutative property under addition. Whenever you interchange the number, you will get the same number, and this is a property of commutative property under addition. Now we will check for the subtraction. Whether the commutative property will fulfill under subtraction or not. Now you can see this is basket of orange, and in this basket there are 5 orange. If I take out 2 orange from this basket, what I will get? I will get 5 minus 2, that is 3. But in this basket I have only 2 oranges, and if I will ask you to take out 5 oranges from the basket of 2 oranges, is it possible to take out? No, it will not possible. So here 2 minus 5, you will not get 3. Yes, that means 5 minus 2 is not equal to 2 minus 5. That means A minus B is not equal to B minus A. Hence, commutative property under subtraction will not fulfill. That means in commutative property, A plus B equal to B plus A, but A minus B is not equal to B minus A. Now we will going to check for the multiplication, whether for multiplication commutative property will fulfill or not. Now I have one example. You can see there are number of orange, 2 rows of 3 balls. You can take example of orange as well as you can take example of balls. So there are 2 rows, and each rows there are 3 balls. That means 2 into 3 is 6. The number of total balls are 6. You can count from here. And in this figure you can see there are 3 rows, and each row is having 2 balls. That means 3 into 2 is equal to 6. You have changed the number of rows, but the number of balls and both the figure are same. That means whether you multiply A multiply with B or B multiply with A, in the both condition you will get same result. As you can also take one more example. Everyone knows table, right? So 3 multiply with 5 is 15, and 5 multiply with 3 is also 15. You are getting the same result. That means commutative under multiplication, it will fulfill. So A multiply with B is equal to B multiply with A. Okay, now we will going to understand whether this condition will fulfill under division or not. Let's check. So I have one example. This is Ram and this is Sita. And both are having two chapatis. Right? So there were total 4 chapatis and it is easy to divide two chapatis between Ram and Sita. But when there are four kids, so how we will divide 2 divided by 4, because there are 4 kids and there are 2 chapatis only, right? So you can see Ram will get half chapati, Sita will get half chapati, Ramesh will get half chapati and Riya will get also half chapati. That means, is half is an integer? No, it is not an integer. 4 divided by 2 is 2. That means here we are getting integer. But in this case we are not getting integer. That means for division the property of commutative will not fulfill. Because in both case you have to get integer. But in this case you are getting integer, but not in this case you are getting integer. Right? That means A divided with B is not equal to B divided with A. Because half is not an integer, it is a fractional number. Right? It is a fractional number. If I get any number like -4 or -5 or 5 or 6, that is integer, and for commutative it is important to get same result. If I do operation A divided by B and B divided by A, we should get same operation, same integer, but for division we will not get. That means commutative property is only satisfy for addition and multiplication, but not for subtraction and division. Hope you have understand the concept of closure property and commutative property. In next video, I will make you understand about associative property. Okay, thank you for now. Thank you for watching the video.